Hi, this is going to be the third lab, okay? And we are going to study ideal gas laws. And when you click on models, you will find there is a homepage called Lab 3 Ideal Gas Law, and you will be able to view this document as your, I will say, instruction page, okay? Now, for this lab, starting this lab, remember you have a video. I'm gonna add a rubric item that is gonna say, watch the video, and you should watch the whole video. Each one in the group should watch that video. And this is gonna worth 40 points of your lab report. If you will not watch the lab, I will get these deducted from your lab report, and it's gonna be added to the rubric. And I can check it by so many methods. One of the things is gonna show here, I did not work on this yet, is gonna show here that you need to complete one item, and that one item is gonna to view. But here, you know, I can check if you did view the whole video or not when I go to the studio setting. Okay, then this is an added thing to your course, and you should watch the video, the full it's not like part of it, like all of it, okay? And both in the group you should watch the video. This is part of your assignment. Now for today, we're gonna study the ideal gas law, and we are going to analyze the behavior of gas. We are going to study, how really changing one of the macroscopic, let's say macroscopic, I will say, variables is gonna affect one other, parameter or a variable. Now, the first thing here, this is your predictions, and this is, I want you to add, of course, we are going to submit 2 files for this lab. One of them is the Excel file, because we're going to do for sure Excel here, graphs, and the other one is the formal lab report, and it should be a Word document that have a cover page, abstract, equipment, and then a procedure, and then data, calculations, and also in the calculation section you should show sample calculations. You should have all your graphs copied from the Excel into your Word document. You should also talk about your results in the results section, and you should have a conclusion, and if there are really questions, you're going to answer them. Also for today, you are going to, this is before the data section. Okay, then it should be added before the data section. You are going to say either predictions or pre-lab. Now, this is the I would say the simulation that we are going to use. And let me click on that and move to it, and then I'm gonna start reading from my document that I have printed here. All right, the first thing, the first relationship we want to investigate, it is between pressure and volume at a constant pressure. You should click on this ideal, and I will say we're gonna pump a quantity of gas in the container, whatever like you are comfortable with. 1, 2, 3, 4. Okay, then a certain amount, and under hold constant, check the temperature. Then we're gonna have the temperature here constant, and we are going to change the width of the container, and our objective from changing the width is to change the volume. Now here, listen carefully to what we need. We need, of course, to calculate the volume, and this is assumed to be a box. Then I will say we are going, this is not written in the handout. You're going to change the width from 5 to 15 in increments of 1 nanometer. And we are going to consider the length of the container to be 12 nanometers. And I want you to consider the other, which is the height, to be 5 nanometers. Okay, then here, again, I'm gonna repeat that. Okay, this is a box that we have the gas in here. And then I want you to have change the width from like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And remember, this is nanometers. Then when we are going to calculate any quantity, this has to be converted into meters. And I will say the length is 12 nanometers. And I will say the height is going to be 5 nanometers. Now you are going to record your data in a table and label it as part 1. And then you are going to calculate the volume of the container, which is the same as the gas volume. And we're gonna calculate this under the calculation section. Okay, then here, what you need to do always is, let me say here, I will have the width here. Okay, we said we're gonna change it from 5. Then here, I am at 5. I will record the width. I'm gonna record what is really the pressure. Okay, like there are variations in the pressure, but it's gonna be around a value. And then I'm gonna move to 6. And then I'm gonna read the pressure again and go on. And then finally, I'm gonna graph pressure versus volume and compare it with your predicted one. Okay, you are going to graph then pressure versus, again, another graph, pressure versus 1 over the volume. And then you are going to suggest and describe a method to calculate the temperature of the gas from the second graph. All right, this is gonna be one of the questions that is gonna be listed under question sections that you are going to add, and you're gonna say questions part 1, questions part 2, questions if I have more questions. All right, then this is the first part. Now the second part is gonna be we want to investigate the relationship between pressure and temperature, and then we are going to keep the volume constant. Again, we're gonna pump. I already have it, but I will say under a quantity of gas, I don't want to pump, I have it already. Under hold constant, check the volume. Then instead of having that, I will have the volume. I will have the volume constant, and then I will start warming or cooling the gas till the temperature is 100 K. Okay, and I will read. Okay, then here I need to go to, oh sorry, I need to go to 100. Okay, then this is 100K. And I will start reading the pressure. Then I wanna start increasing the temperature up to 300 Kelvin in the steps of 10K. Then I'm gonna have 110 now. And then, I did move, too many. I don't want to do one. Okay, yes. This is 100. Then I'm gonna now go easy on it so that I will have it 110. Okay, and then I'm gonna read the pressure. And then I'm gonna change this to 120 and read till I reach 300 Kelvin. You're going to record the data under the data section, and you're gonna call that part 2. And you are going to graph pressure versus temperature and compare it with the predicted one. Now, part 3, we want to investigate the volume and temperature at constant pressure. Okay, then we are going to here understand and find the relationship between volume and temperature at a constant pressure. Then here I will say we're gonna hit this, and we are going to start again, check the pressure, and then what we are going to do, change the width from 5. Oh, what did I do? Okay, it should be this one, the pressure T. Okay, and then I'm gonna start changing the width again from 5 to 15. Calculate the volume the same way that we did in part 1. And every time we need to find what is going to be the temperature for each volume. All right, reading what is really the temperature for each volume. And we will record our data in a table, and we're gonna call it part 3. Under calculation, you are going to calculate the volume again, having the I will say the width from 5 to 15, and having the length at 12 and the height as 5. We are going finally to graph volume versus temperature and compare it with our predicted one. Okay, now, okay, that table here that is in the last page, page 3, complete this table, should be in your results section. Okay, now there are also a set of questions that you need to read and answer under the section which is called questions. Okay, this is for this lab, and thank you.